This is the experiment that changed everything, a phenomenon that shattered classical physics. In the 17th century, Isaac Newton claimed that light was made of tiny corpuscles, projectiles of particles traveling in a straight line. But in Holland, another genius thought differently. Christian Huygens imagined light as a wave, spreading like sound in the air or like ripples on water. The nature of light was in a dilemma. Is it a wave or a particle? There was no consensus until in 1801, Thomas Young performed an experiment. With just 2 slits in a piece of cardboard and a beam of light, he changed everything. If we throw marbles at a wall with 2 openings, 2 bands appear. All logical. Now, let's try with waves. 2 slits and an interference pattern emerges, with multiple bands created by waves crossing, reinforcing, or canceling each other out. When Young made light pass through 2 slits, he didn't see 2 simple bands. He saw the indisputable proof that light is a wave. 100 years later, Max Planck proposed that energy is emitted in tiny discrete units, quanta. And in 1905, Albert Einstein, while explaining the photoelectric effect, showed that light also behaves like a flow of particles striking electrons, photons. Classical physics was crumbling. Duality was inevitable. Light was both a wave and a particle at the same time. But physicists wanted to go further. They took the experiment into the quantum realm with the smallest particles of matter. They fired electrons one by one through 2 slits. They expected 2 bands like with the marbles. But no, an interference pattern appeared. Tiny pieces of matter forming a pattern like with waves. The conclusion was clear. Each electron left as a particle became a wave, passed through both slits, interfered with itself, and struck the screen. Which meant that the electron went through 1 slit and through the other, through both, and through none. All those possibilities superposed at once. Bewildered, physicists tried to measure it. They placed a device to observe which slit each electron passed through, and the unexpected happened. The interference pattern vanished. The electron drew 2 bands, like a simple marble. The mere act of measuring changed the result. The electron behaved differently, as if it were aware it was being observed. From then on, science ventured into the enigmatic quantum world. So what is matter then? A handful of tiny particles? Mysterious waves? Or something that only exists when we observe it?